This lecture is on alcohols. In this section, we are going to cover the structure and nomenclature of alcohols. Structure of alcohols. The functional group present in alcohols is an OH group. This OH group is actually connected to an sp3 carbon. This is your sp3 carbon. And we already know that the bond angle in an sp3 carbon is about 109.5 degree. And the oxygen here is also sp3 hybridized. The two sp3 hybridized orbitals form two sigma bonds, one with carbon and other one with hydrogen. And the two remaining sigma bonds will exist as two lone pairs on oxygen. The bond angle here is 108.9 degrees. Nomenclature of alcohols, IUPAC names. The first thing to do to find the IUPAC name is to find the parent chain. The parent chain here is the longest carbon chain that contains the OH group. And remember, this OH group should have the lowest possible number. And then finally, change the suffix E to all. Here is a simple alcohol. We can imagine that this alcohol has been derived from methane. Let me draw the structure for methane. So here is the structure for methane, where you can see that there are 4 hydrogens that is attached to carbon. If I'm going to replace one of the hydrogens with an alcohol, with an OH group, then it's going to become an alcohol. So here is my alcohol. So remember, methane had the formula CH4, and we converted that into methanol, into an ol. Okay, where you can see that the E has been replaced with an ol. And using this as an example, you can find the name for this. This should be ethanol. Coming to the common names, we have to name the alkyl group bonded to the oxygen followed by the word alcohol. If we want to give a common name for this molecule, it's going to be methyl alcohol, since this part is going to be acting as a prefix and this is going to be suffix. So this would be methyl and this part would be alcohol. Methyl alcohol. And similarly, the other one would be ethyl alcohol. Classification of alcohols. Alcohols can be classified as primary, secondary, or tertiary. Here is your primary alcohol. Why this is a primary alcohol? Now the OH is connected to a carbon which is connected to one other carbon, and therefore this is a primary alcohol. And this one is a secondary alcohol because this carbon where the OH is attached is connected to two other carbons. Remember, the R group is actually going to represent the alkyl group, and therefore this is going to be secondary. And this is a tertiary alcohols because this carbon is connected to 3 other carbons. Nomenclature. Let's do some examples on nomenclature. We want to find the name for this molecule, very first molecule. Okay. Here we have the OH as the functional group. Keep in mind that this OH needs to get the lowest possible number. You can go from left to right, right to left, or in any direction, but you need to make sure that the OH needs to get the lowest possible number. So the best way to have the OH with the lowest possible number is to number the carbons from left to right for this molecule. 1, 2, 3, 4. Since it has 4 carbons, it should be called as butanol. And you also needed to give the position for the hydroxyl group. The hydroxyl group is actually present on the second carbon, so you have to write it as 2-butanol. Or another way to write this compound is you can write it as butane 2-ol. Either way, it should be right. Now let's do the third example. In the third example, we have 2 functional groups. We have an alcohol and we also have an ether. So here we need to decide which one gets the priority, right? On the ether you have 4 carbons, and on the carbon and on the alcohol you have 3 carbons, right? Okay, but that's not what is going to decide the priority. Here is the chart that's going to decide the priority. So between ether and alcohol, alcohol gets the priority, so it should be assigned the parent name. right? Meaning that it should be given the lowest possible number. So I'm going to actually start the numbering 1, 2, and 3, and the rest of the things is going to act as a substituent. So this whole part is going to be acting as a substituent on the third carbon, right? So this can be named as propanol. To be more specific, it's going to be 1 propanol, right? And since this is a butoxy group, which has 4 carbons, it should be a 3-butoxy that comes in front of 1 propanol. So 3-butoxy, 1 propanol. Or you can also write this as 3-butoxy, propan, 1-ol. Either way, it should be right. We have an hydroxy group, we have an alcohol, and we also have 2 methyl groups. Here again, you need to make sure that the OH group is actually included in the longest chain. So the longest carbon-carbon chain is going to be this one, which has 1, 2, 3, 4, 5 carbons. Of course, you can also go in this direction, right? So this should also be right. This should also be right, right? So even if you consider it in any case, you can definitely see that there are 2 substituents, 2 methyl group as substituent. So how are we going to name this compound? So which direction are we going to go in? So you're going to count the carbon in this direction from right to left. 1, 2, 3, 4, 5. So that's going to be 2-pentanol. And then leaving the 2-pentanol, okay, I have 2 methyl groups. And where these methyl groups are present, they are present on the 4th position. So it should be written as 4,4-dimethyl 2-pentanol. That should be the name for this molecule. Some more examples. For this compound right here, whether you count from left to right or from right to left, the OH group is still going to be on the 3rd position. So let's put the numbering on. So OH group is on the 3rd carbon, right? So the name for this molecule is going to be 3-pentanol. Because there are 5 carbons, it should be having pentanol, and because the OH group is present on the 3rd carbon, it's going to be 3-pentanol. And for the next compound, you need to make sure that you find the longest carbon-carbon chain where the OH is present, including the OH, right? So this is going to be my longest carbon-carbon chain. And leaving that, the rest of the thing is going to act as a substituent. Here is my substituent, right? And you need to make sure that the OH gets the lowest possible number. So that's going to be 1, 2, 3, 4, 5, 6. So this is going to be hexanol, but you also need to give the position for the OH group. So that's going to be 1-hexanol. And leaving that 1-hexanol, I have a methyl group on the 3rd position. So this is going to be 3-methyl 1-hexanol. Make sure to separate the alphabet and the number using a hyphen. Or you can also call this as 3-methyl hexane 1-ol. Either way, it should be right. When there is both a functional group and a substituent, the functional group gets the lowest possible number. So here is where you will be using the chart that I showed 2 slides ago. Okay, now let's take the very first example we have. So in this first example, you have a functional group. Alcohol is the functional group, and you also have a substituent. The Br should be considered as a substituent. Alcohol, and you have Br. So in which case the alcohol gets the priority, right? So we have to make sure that the alcohol, that the carbon where the hydroxy group is attached gets the lowest possible number. So let's number the carbons 1, 2, 3. Okay, and because there are 3 carbons, it should be propanol. It should be 1-propanol. And leaving that part, I have a bromine. But where this bromine is attached, it is attached on the 3rd carbon. So it's going to be 3-bromo, 1-propanol. Let's do the next example. Again, you have you have a substituent here, and you also have the hydroxy group, which is your functional group. Here again, you need to make sure that the hydroxy group gets the lowest possible number. So you have to go from right to left. That way, the OH group gets the lowest possible number. But if you go from left to right, this carbon is going to be 3, right? So you needed to make sure that you go from right to left in this case. Okay, 1, 2, 3, 4. Okay, because there are 4 carbons, it's going to be butanol. And where is this hydroxy group present? It's actually present on the second carbon, so it's going to be 2-butanol, right? And then leaving this part, we have already given the name for this part, right? We are just left with the chlorine. And where this chlorine is present, it's present on the 4th carbon. So it's going to be 4-chloro, 2-butanol. Now let's identify the functional group. The functional group right here is an alcohol. And leaving that alcohol, you also have a substituent. Okay, now which direction you want to go in, from left to right or from right to left? When you go from left to right, that puts both the chlorine, which is a substituent, and as well as the functional group with the lowest possible number, right? But if I'm going to go in the other direction, 1, 2, 3, 4, the hydroxy group is actually on the 3rd position and the chlorine is on the 4th position. Definitely those are higher numbers, right? So the proper way of numbering this compound is from left to right. Okay, let's find the name for this. Because it has 5 carbon in the parent chain, it's going to be called as pentanol. And the hydroxy group is actually present on the 3rd carbon, so it's going to be 3-pentanol. And the chlorine is present on the 2nd carbon, so it's going to be 2-chloro, 3-pentanol. It should not be named as 4-chloro, 3-pentanol. Okay, now let's go on to the next one. Let's see. So here, whether you go from left to right or from right to left, the OH is actually on the 4th carbon, right? But if you go from right to left, that also gives the substituent the lowest possible number, right? So I'm going to go from right to left. 1, 2, 3, 4, 5, 6, 7. If I go from left to right, then that puts the methyl group in actually the 6th position. You definitely don't want to give a higher number when you can give the lowest possible number, right? So the hydroxy group is actually on the 4th position and your methyl group is on the 2nd position. So let's name this one. So this should be 4-heptanol. And you have a methyl group on the 2nd position. So it's going to be 2-methyl 4-heptanol. Let's do an example where the OH is present on a ring, for which you have to assign the ring to be the parent name, right? Followed by the alcohol. Let's find the total number of carbons present in this ring. So it has total of 6 carbons, right? So this should be derived from cyclohexane, and because you have a hydroxy group, it should be named as cyclohexanol. Remember, you have the functional group here, and you also have the substituent. You need to make sure that the hydroxy group gets the lowest possible number. So I'm going to number, this is number 1, this 2, and 3, right? So it's already assumed when you have hydroxy group, it's already assumed that the hydroxy group is going to take position number 1, so you don't have to specify that in the structure, in the name. Okay, so let's find the name for this molecule. This is going to be cyclohexanol, and you don't have to put the 1 in front of it because it's already assumed that the hydroxy group is going to be at position number 1. Okay, so leaving that, you're just going to give the number for the substituent. It's going to be 3-methyl cyclohexanol. Okay, I hope it makes sense. If there is more than one substituent, they are listed in alphabetical order. Okay, so now let's see some problems under this category. Okay, let's identify the different substituents and the functional group. Let's identify the OH. The OH group is right here, and here is my substituent. Here are my substituents. Okay, by default, you need to make sure that the hydroxy group gets the lowest possible number, right? So I'm going to go from right to left. That way the hydroxy group gets the lowest possible number. Here's my longest chain, right? So 1, 2, 3, 4, 5, 6, 7, 8. So that is going to be octanol And the hydroxy group is actually present on the second position, on the second carbon, so it's going to be 2-octanol. And leaving that, I have a bromine and I also have an ethyl group. Okay, so which one comes first? Bromine needs to come first, right? So it's going to be 7-bromo, and then I have 4-ethyl because B comes first and then comes E. So the right name for this compound is going to be 7-bromo, 4-ethyl, 2-octanol. Okay, so make sure that you're alphabetizing if you're going to have more than one substituent. Okay, let's do the next example. Okay, the next example is actually is where you have your hydroxy group on a cyclic structure. Okay, now find the number of carbons in the cyclic structure. This is going to be cyclopentanol, right? By default, this carbon is going to be number 1, right? And you need to reach the second and the third substituents with the lowest possible number. And which direction are we going to go in? Clockwise or anti-clockwise, right? We have to go clockwise. So which means this methyl group is going to be 3 and the other methyl group is going to be at 4. Okay, let's name this molecule. This is going to be cyclopentanol, and you don't have to put the 1 in front of it because it's already assumed that the hydroxy group is at position 1. Okay, and I have 2 methyl groups. Let's highlight the methyl groups. I have 2 methyl groups and they are at position 3 and 4. Since there are 2 methyl groups, you can use the prefix di. So it should be 3, 4 dimethyl cyclopentanol. The next problem has an hydroxy group and on a cyclohexane, right? So by default, this is going to be number 1. Now, which one is going to be number 2? Which side? Are we going to go clockwise or anti-clockwise? Remember, this is going to be your functional group. And here are your 2 substituents. You have an ethyl group. And this is your methyl group. So which direction are we going to go in? Okay, obviously this is going to be number 2, right? So you need to make sure that you get the lowest possible number for all the substituents. So if I'm going to assign this as number 3, if I'm going to go in this direction, then that puts the ethyl group in the 6th position, right? So you have to try to avoid the highest numbers. So 3, 4, 5, 6, right? And the parent name is going to be cyclohexanol, and you don't have to put the 1 in the front of it. And it's going to be 2-ethyl and 5-methyl. And here again, you can see that we are alphabetizing. Okay, you need to make sure that you put the ethyl first and then comes methyl. Okay, if I number in the other direction, let's say that I'm going to number it in this direction. That puts the methyl group at the third position and the ethyl group in the 6th position. And obviously you can see that 6 and 3 are higher numbers when compared to 2 and 5. So you definitely want to avoid that. Now the next thing is when you have multiple hydroxy groups, then you have to use the prefixes di, tri, and so on. Okay, here is a compound which has 2 hydroxy groups. Okay, let me highlight the hydroxy groups. And both of these hydroxy groups need to get the lowest possible number. When you go from right to left, that puts the hydroxy group in the 3rd position, whereas when you go from left to right, that puts the hydroxy group in the 2nd position. You definitely need to go from left to right. That way, both the hydroxy groups get the lowest possible number, right? So 1, 2, 3, 4, 5, 6. This has been derived from hexane. So it's going to be hexane. And remember, you have 2 hydroxy groups, and therefore it should be written as diol. Diol. And where is these alcohols present? Where is these hydroxy group present? They're present on the 2nd and the 4th position. So it's going to be 2, 4 hexane diol. Or you can also write this as hexane 2, 4 diol. Either way, it should be right. You can put the numbers in between hexane and diol. Okay, let's identify the name for this molecule. Again, which one is going to be assigned as number 1? Which direction are we going to go in? Okay, yes, from left to right. Okay, let's go from left to right. 2, 3, 4, 5. So here is your hydroxy group and your hydroxy group, and here is your substituent. Okay, so this should be pentane diol, right? Pentane diol. And where these hydroxy groups are present, it's actually present on the second carbon and the third carbon. So it's going to be 2, 3 pentane diol. But you also have a substituent here. The substituent is actually present on the fourth carbon, right? And therefore it should be 4 methyl 2, 3 pentane diol. Or you can put the 2, 3 in between pentane and diol. Okay, either way it should be right. Okay, let's identify the name for this molecule. This molecule has 3 hydroxy groups. Okay, so here are your 3 hydroxy groups. And therefore, by default, it's going to be triol because it has 3 hydroxy groups. You need to use the prefix tri. Okay, and when you count the carbons, it's going to be 1, 2, 3. And you can also count in this direction 1, 2, 1, 2, and 3. So either way, it's going to give you exactly the same number, right? So because it has 3 carbons, it's going to be propane. And the hydroxy groups are present on first carbon, second carbon, and third carbon. So it's going to be propane 1, 2, 3 triol, or you can also write it as 1, 2, 3 propane triol. Either way, it should be right. Unsaturated alcohols. In an unsaturated alcohol, you can have one or more double bonds or triple bonds. Okay, where you're going to change an an into an ene, and then you're also going to add the suffix of ol. Remember, here again, you need to make sure that the hydroxy group gets the lowest possible number because that's going to get the highest priority. Between a double bond and a hydroxy group, or between a triple bond and a hydroxy group, obviously the hydroxy group is still going to get the highest priority or the lowest number. Right, so this is going to get the lowest possible number. And let me count the total number of carbons. It's going to be 6, and therefore it's going to be hexane, right? Hexane. And where is this hydroxy group is present? It's actually present in the first carbon, so it's going to be 1 ol. Okay, why it should be hexane? Because you already have a double bond. If you don't have the double bond, then it should be called as hexanol, hexane 1 ol, right? Because you have the double bond, you have to write it as hexane 1 ol. So leaving that hexane 1 ol, you also need to assign the number for the double bond. The double bond is actually starting at carbon 2, so it should be 2 hexene 1 ol. And if you want, you can also include the stereochemistry. You can definitely say that this hydrogen in this hydrogen or in an opposite direction, and therefore this is a trans compound, so you can put the E in front of it. So it's going to be trans 2 hexene 1 ol. Here are some more examples for you guys to practice. See if you can write the name for these molecules.